We're learning about light, and light can interact with substances in several ways. One way is it can reflect. Okay, so a substance or an object can reflect the light. It can refract, and it can diffract. The light can be absorbed. We're going to talk about each of these in more detail, but reflect, of course, you just want to think of as it bounces off. So no change in the wave, it just kind of bounces off and changes direction. Refract is when the light bends or changes direction. When it goes from one medium to another, to a different medium. So when light passes from water into air, it will refract. Diffract is when it changes direction. I don't know why my pen is not working very well again. Changes direction. When it passes the edge of a barrier. And then absorbed, of course, that energy is absorbed, that light energy is absorbed. And in fact, in some cases, the object will actually get hot if, depending on the type of light that it is. And light being energy, being a wave, we can have the light be absorbed by the object. So light can interact in these four ways: reflect, refract, diffract, and absorbed. All right, so there are three types of materials, and we categorize them on how they interact with different types of light. And don't forget, when I say light, I mean anything on the electromagnetic spectrum. So our first type is opaque. Opaque blocks all the light, or that type of light that you're talking about. So it can block that light. And this is where you want to be, you will absorb or reflect the light. So if you recall what we just talked about, an opaque object will block, absorb, or reflect the light. So if you want to think about this, these kind of objects will create a shadow. Okay. Examples, of course, a rock, if you will block a visible light. Another example is a lead vest. Right? It is opaque to X-rays. That's what they put on you when you get an X-ray. Our second type is transparent. Transparent is something that lets the light pass through it. Okay, so of course this is a window, if you will. A window lets all visible light through. And our third type is translucent. And this is something that blocks some light and lets other light through. Okay, so it'll block certain types, but let other types of light pass through it. So it'll be translucent. So translucent are things that are, I don't know if my pen would work here. You know, you can't quite see through it, but it's not opaque. It's you know, like frosted glass. Okay, that is translucent. If you try to look through a piece of, you know, like wax paper, that is translucent. You can kind of see, you know, something behind there, but it's not going to be transparent where you can see everything. So we kind of categorize our three types of materials as opaque, transparent, translucent. And you know, there's other categories, I'm sure, but we're just going to keep it simple here in our introductory physics here. So next we're going to talk about reflection and the law of reflection. So for our opaque objects, we can have the law of reflection take place. And that is, please understand I tried to draw this and put it in to make it look even. But the law of reflection says that the angle of incidence has to equal the angle of reflection. Angle of incidence is your incoming light. And your angle of reflection is the outgoing light. Now, all flat mirrors, of course, will follow this and make it easy to see. This is always happening, really, but how many objects are perfectly flat and smooth in your everyday life? So it's hard to notice this. But for our law of reflection, basically says, again, angle of incidence equals the angle of reflection. Now our angle of incidence, I'm just going to say angle I up here, and our angle of reflection, theta r. Now this dashed line is super important. This is called the normal. We talked about that before in physics, but that's your perpendicular bisector, if you will. Perpendicular to the mirror or your opaque object. Now all light will follow the law of reflection. Okay, so the angle in has to equal the angle out. Angle of incidence equals the angle of reflection. So if the surface is not perfectly flat, you can get scattering of the light. And this is probably more common. Again, if you're looking at your flat mirror in your house, you're getting the law of reflection. But scattering would be, you know, a normal light bulb. You want it to scatter the light so that it brightens the whole room instead of just a small section of the room. But they're still following the law of reflection. It's just with that uneven surface, it's going to give you a lot more diversity and everything in your angles of incidence and your angles of reflection. Let's look at the law of refraction, or sometimes called Snell's law. So law of refraction says when an object passes from one medium to the other, so let's say this is air and it's going to go into water, okay, the light ray will refract. Okay, so as the air goes, or as the light goes from air to water, it will refract or change direction. So if this, I'll make up a number, 30 degrees, this angle down here might be like 15 degrees. Okay, and if we were going the other way, if we were going water into air, okay, again, if this is 30 degrees, this might be, I don't know, 65 degrees. Again, I'm making up numbers, even though here in a second we're going to be able to calculate that. So the light will change direction as it goes from one medium to the next. And that's why your straw will look bent in a cup of water, right? So if our straw, I forget exactly how it looks, but it will look something like that. And there's our straw. Okay. Now, to keep in mind is if you look from the top, the straw will look perfectly straight. This only works from the side view, because here your angle is 0 degrees, looking straight down. And so you will not get any refraction in that case. It's got to look at it from the side as it changes from the normal. Okay. Snell's law, we can actually calculate this. N1 times the sine of the angle 1. For example, if this was air, you would say N for air, or sine of angle of air. The second substance and the change in the angle as it moves into the second substance, whether that might be water or something like that. N's are the index of refraction. As I run out of room here. And the theta is the angle measured from the normal. Okay. So the normals, again, are those perpendicular lines that bisect, if you will, the light rays. Of course, bisect implies the angles are the same. It doesn't have to be, symmetrical angles. Usually the index of refractions will be given in the problem, and then the angles is what you're solving for. One thing to note that N for air is our baseline. I don't know why this pen just does this every time. It's annoying. Is 1.00. So that's our baseline. I believe water, I'm going off the top of my head here, is like 1.33. Don't quote me on that, but I think that's what it is. And one thing to keep in mind as you go from air to water, the speed of light will slow down. Okay, and so if you go from fast to slow, you will bend towards the normal. Fast to slow. You will move towards the normal. And of course, in that second example, you're going from the slow water to the faster air. Notice you bend away from the normal. Okay, so I think this gives you a pretty good introduction to some properties of light and how it interacts with materials in the everyday world. We've talked about reflection, refraction, diffraction, and everything like that. So we're going to obviously practice some of these. Snell's law, of course, that's an equation. You want to make sure you practice these types of questions there. And yeah, we'll go from there. Let me know if you have any questions.